Hello everyone, this is Himabindu from the Department of Computer Science and Information Technology. Today in this video, I would like to explain about the non-deterministic finite automata examples. And here I have to discuss about how to construct a non-deterministic finite automata. So previously in this video, previously we decided that the finite automata is having non-deterministic finite automata and deterministic finite automata. In the previous video, we discussed how to construct a deterministic finite automata with examples. And now in this video, I would like to explain about the non-deterministic finite automata construction and with the examples. So let's move on to the slides. And here is the definition. So it is having some characteristics. Non-deterministic finite automata. We'll simply represent it as a NFA. So in NFA, it is having the two characteristics. So one is the E transition, like epsilon transition, and second one is the non-deterministic non-determinism. We'll say that these are the two characters for the NFA. NFA is the non-deterministic finite automata. The state transition can be made without reading a symbol. It's called as the characteristic epsilon transition. And second one is the characteristic, it can accept 0 or more than possible values may exist for the state transitions. These are the two characteristics which are having with the NFA. And what is the formal definition of this NFA? So it is also same like previously we discussed about the DFA. It is a phi tuple. So here it is this is also phi tuple. So in that phi tuple we have the values m is equal to. So here m is nothing but NFA and it is having the phi tuple. So Q sigma and delta and Q initial state and final state. So we'll elaborate this one. The Q is nothing but the set of set of the states which are involved in the construction of NFA, and the sigma is the values which are the having in the strings like zeros, ones, A, B, C. What are the things in all the alphabets which are involved in the NFA. And next Q naught is the starting state. To construct a NFA, we need the states, initial state and final states. In between, we have to add some acceptance states. Like that, here also in a NFA, we have an initial state is represented as a Q naught. And next to F is the final state, a set of accepting states. And delta is the transition function which is mapping between the Q and sigma. So these are the things which are having with the phi tuple notation. Next, move on to the slide. And how to use this NFA. So what is the use of this NFA? So if you give any input to the finite automata, how it is going to construct an NFA. So here is the steps and input. So input is the word W in sigma star. So here the sigma star is representing as a list of all the languages which are possible with the alphabets sigma. And question is W acceptable by NFA? So what is the string? So here W is the word which is in sigma star. So it is acceptable by NFA or not? We have to check with the steps. So what are the steps involved in the construction of NFA in the sense? So first, as usual, in DFA we have starting with the Q naught. Here also we have to use the Q naught is the starting state. And next, for every input symbol in the sequence W do, we have to write all the possible strings in the states one by one. So here we have to initiate the starting state, and how many strings or how many alphabets are involved in the W, we have to construct according to that one. And the third step is about if after all symbols in W are consumed and if at least one of the current states in the final states, then accept W. So here we have to consume all the strings in all the elements, all the alphabets in the W. After that, if it is not reaching the final state, it should be rejected. So it is not a possible NFA construction. So let's see with the example with the construction of NFA by step. So here is the example with the NFA, construction of NFA for the strings containing 0, 1. So 0, 1 is the string. So it is, we can say that this example with the string contains 0, 1 as a substring. So here we just elaborate the this question, and here the sigma is the alphabets 0s, 1. 0, 1. So in alphabets, with this alphabets, we form the string. What is the condition in the sense? The language which the substring 0, 1. So either it starts with 0, 1 or ends with 0, 1. It should be having the substring 0, 1. So 0, 1 we'll just elaborate this language. L is equal to, so minimum length of this one is 0, 1. So it should be there. The condition is like the substring should be 0, 1. So I am initiating with this one, and after that, so we can add something to in between this 0, 1. So 0, 1 is the substring, and we can add in starting or ending like this. And this is the length 3, and this is the minimum length 2. And if you add 2 starting and ending at the same time, it's just like this. 0, 0, 1 is the substring and 1 is the ending thing. So here is the condition. The substring should be 0, 1. And like that, 1, 0, 1, 0. So this is another possible substring with the 0, 1. So these are, we can form these many strings with this language which contains the string having substring 0, 1 as a substring. So how to construct a NFA? The first step is to start with the starting state. Here is the starting state. We are representing Q naught as the starting state, and next we have to write the next minimum length is 0, 1. So we have to represent with the 3 states. So here the question is how to write the states, how to find how many states in the NFA construction. First thing, the minimum length is here 0, 1. So here the minimum length plus 1. These many states is equal to states. So here minimum length is 2 plus 1. So we need 3 states. So here is the Q naught is the one state, and Q1 is the one state, and Q2 is the one state. So these are the 3 states which are involved in the construction of this NFA. And let's minimum length is 0, 1. We have to satisfy this first condition. So here we have initiated with the Q naught, and after that we are giving the 0 and 1, and it is reaching the final state. So this string is accepted by this NFA construction. Finally, it is reaching the final state. How to construct a NFA for this kind of thing in the sense 0. So in starting state 0, 0. So how to repeat the 0, we need to add 0, and at the same time I had to add 1. So what is the main difference between the NFA and DFA is nothing but, so in DFA, so if it is the Q naught is the initial state, for one input symbol, we have to move to the only one state. This is DFA. In NFA, if you take Q naught as the initial state, and if it is having 0 and 1, it should be. So here is the main difference. So in DFA, we'll just take only single input symbol. But in NFA, we can take multiple input symbols, 1, 2 or many input symbols. What are the possible input symbols with that string? We have to add in the NFA construction. So that is the main difference. And next, so here is we satisfied both the two. Like here it is also having the 1, 0, 1. So these two are satisfied with this condition. And if we add ending many, what is the ending symbol is, we are not having a condition, like there is no ending with the ending with the some alphabet. So there is no condition, in the sense we have to write like loop. So here the string should end with either 0 or 1. So if this is the NFA construction for the substring, and the substring 0, 1. So what is the next step, in the sense we have to elaborate the things, like previously we discussed the 5-tuple notation. So in that 5-tuple notation, by using this transition diagram, we will write this how many states, in the sense Q is the final set of states. So Q naught and Q1, how many set of states is nothing but here Q1, Q2 and Q naught. And sigma is nothing but it is having the 0, 1. So the strings which are combinations of all alphabets with the 0, 1. And start state is a Q naught and final state is a F2. Sorry, Q2. And next, transition table. So how to construct a transition table? So here this is a transition function, and with that how many input symbols we have, and we have to multiply with the how many states involved in the construction of NFA. Here we have 3 states. So here and 1, 2 alphabet symbols with the combinations. So here we have to start with a Q naught, and arrow mark should be representing like start state in the table, transition table. And final state should be represented with a star. And here starting state Q naught, from starting state Q naught, we are giving the input symbol 0, 1, 0, 1. So here for 0 input symbol, how many states it is reaching? So from Q naught 0, if you are giving 0, and it is self-looping like Q naught and Q1. So both states should for 1 input symbol. Like that, here for, from Q naught, 1 as an input, only it is reaching the Q naught only. Like that, we have to construct a transition table for the construction of NFA. Let's move to the next example. And here is the example about build a NFA for the language L is equal to W. W is the binary string starting with the 0, 1 over the input alphabet. So here same example, like previously we discussed about the substring of language, substring of the word. And here we have to the condition is starting with the 0, 1. So starting with the 0, 1, in the sense we just elaborate this language. So 0, 1, the minimum length is 0, 1, and starting is 0, 1. After that, we can add so many elements, like either we can add 0, we can add 1. And next, the starting must and should 0, 1, and we can extend the link with the 0, 0, 1, 1, 1, 0, 0, 1. So the condition must be satisfied with in every string. So 0, 1 is the starting string. For this language, how to construct a NFA in this sense? First we have to start with the Q naught, and next we have what is the how many states we required for the construction of NFA. We will see. So minimum length is 0, 1. So 0, 1 in the sense minimum length plus 1. So here minimum length is 2 plus 1, 3. So we require 3 states here. So and how many starts with the Q naught, and the final should be the substring. We have to satisfy this first condition. We will see the construction of this NFA. And here is the example with this construction. The starting state is Q naught, and Q1 is the next state, and we have to satisfy with the condition. The language q naught, this string is having q naught comma q1 and q2, and the substring here, the one more example for this one, the string which contains 1 0. The same thing for the 1 0, we will construct a NFA for the thing. And here is the thing, the q1 is the starting state, q naught is the starting state, and q1 is the acceptance state, and q2 is the final state. So it should be satisfied with the 1 0 condition. We can also add this like this, 1 0 condition. And so the first condition should be satisfied, and later after how many are there, it should be satisfied by the loop 0 comma 1. And this is the construction of NFA with the substring, with the construction of NFA with the starting with 0 1 or 1 0. And next example is about construction of NFA for the language ending with 0 1. Here also we have to elaborate the language 0 1 ending with 0 1. So 0 1 is a minimum length. So ending with 0 1 in the sense we can write anything in front of this one. So like either add 0 or 1. And this is the third minimum length 3. And next one we can add 2 more strings like 0 1, 1 0, 0 1. So the 0 1 should be the ending one. And next, like that we can add multiple lines to this one, multiple strings to the alphabets. So here this is the elaboration of the construction of NFA, and here minimum length is 0 1. So minimum length is 2 and plus states. These are the states. We require the states 3. And here are the 3 states we have to require for the end construction of NFA. And the starting state is Q naught and ending state is the Q2. And here is the construction of NFA for the language. So Q naught, so first we have to satisfy this 0 1. So it is reaching the final state. And if you add anything to this string before the ending of 0 1, we have to represent with this loop like 0 1. We can add many times with the 0, and we can add many times 1. Multiple times we can add with the 0 1 for this string. And next example. So design an NFA with epsilon 0 comma 1 accept all strings in which the third symbol from the right end is always 0. So here how to construct this NFA in the sense, first we have to elaborate. The condition is that the third symbol from the right end is always 0. So the condition is the third symbol. So L is equal to, so third symbol from the right end. So here is the third symbol from the right hand in the sense here always 0. So always 0. So the condition says that the third symbol from the right end is always 0. So here we can add either 0 or 1. Here also either 0 or 1. So minimum length is here 3. And next, like this, we can also elaborate the third symbol from the right end, and we can add 0, 1 and 1. So here is the condition, the third symbol from the right end is 0. And like that, we can also add 0 instead of 1. We are replacing with the 0, and third symbol from the right end is 0 must and should, and we can add same thing. And like that, 0 0 0 is the minimum main condition, and we can add like this. Third symbol from the right end is 0. Like that, we can form multiple strings with this combination of language. And for this one, how many states we need for this construction of NFA in the sense minimum length is here 3. So minimum length 3 plus 1 is equal to 4. We require 4 states. Let's see how to construct a NFA for this one. And here is the example. First thing, we have to satisfy the first condition. So first minimum length is 0, or either it is 0 or 1. It should be like this. So here the starting state is 0 and and we represent these conditions with this same representing, like we can add 0, 1 and 0, 1. And next, in case of starting symbol from the right end is 1, it should be satisfied with the 0, 1. And if it is a 0, it should be satisfied with this 0, 1. And like that, how many times zeros once repeat in the construction of string starting, it should be satisfied with the loop. So like this, and finally it should be reaching the final state to the Q3. So here the how many states required for this instruction of NFA, in the sense we require 4 states. Those how to represent this phi tuple for this construction of NFA, in the sense we have Q. So Q is a set of states. So how many set of finite states we have, in the sense Q naught, Q1, Q2 and Q3, and sigma. So it is a combinations of all zeros, 1. And next one, transition functions. So here the transition functions from how to declare a transition functions, in the sense transition function 0, 1, and how many states we have, Q naught, Q1, Q2 and Q3. So for Q naught, how many zeros? For 0 input symbol, it is reaching Q naught, Q1. And for 1 input, it is reaching only Q naught. And for Q1, so for the input 0, it is reaching Q2, and Q1 one input symbol Q2, and from Q2 Q3, and next from Q3, so it is not reaching anything. We will represent like this. So this is the transition function. And next, initial state is the Q naught and final state is the Q3. Like this, we can represent in the phi tuple notation also. And one more example, design an NFA with epsilon 0, 1, in which double 1 is followed by double 0. Double 1 is followed by double 0, in the sense we just elaborate this language. L is equal to double 1. So double 1 followed by double 0. So it is a minimum length which is having the 4 length. So how many states should require for this construction, in the sense we require 5 states. And next, double 1 followed by double 0. So we can add starting and ending. The condition must satisfy like double 1, double 0. Double 1 is followed by double 0. And we can also form double 1, double 0. Starting, ending should be, we can change. So and it is having like either 0 we can use or 1 we can use. And we can also use multiple times 0, multiple times 0, 1, 1, 1, 0, 0, 1, 1, 0, 0. And we can also use multiple zeros, multiple ones in starting and ending. The condition is the double ones is followed by the double zero. So for this kind of language, we require the 5 states. The minimum length is 4. So 4 plus 1, 5. 5 states are required for this one. So let's see. So every time how we are using to construct a NFA, here we have to start with the Q naught, and it is having two final states. How it is going to be? So for this, we have the two conditions should be satisfied. The finite automata with double ones is follows as. So double ones in the sense we require minimum length 3. So minimum length is 2 and we require the states 3. So Q0, Q1 and Q2. And this is the double ones followed by double zeros. So we require another diagram, double zeros. So minimum length is 2 and we require 3 states for that double zero. So listen. Double one is followed by double zeros. We are just combining both two. And here the condition should be the starting and ending should be our decision. So we just take either 0 or 1. So that is the condition satisfied with the self loop. How to construct a NFA for this kind of double ones and followed by the double zeros, we'll see. So we just satisfying with the self loop like 0, 1. So multiple times we can repeat these conditions, like either if you start with 0 and end with 0, it should be satisfied with the double loop. So here are the states. How many states we require for the entire construction of NFA? In the sense we require 5 states. So here the states Q is having the 5 states. What are the names of the 5 states? Q0, Q1, Q2, Q3 and Q4. And next, how to write alphabet? So how many alphabets we have? 0, 1. And next, and transition. So transition requires input symbols with the states. So states are Q0, Q1, Q2 and Q3, Q4. So input symbol 0, 1. So for the construction of Q0 to 0. So for giving input symbol for the Q0, 0 as an input symbol where it is reaching in the sense Q1, Q0. And for the input symbol 1, it is reaching the two states. One is Q0, one is Q1. And from the Q1, 1 as an input symbol. So 0 input symbol is not there. So we can empty that one. And Q1 to 1. So where it is moving in the sense Q2. And from Q2, 0 has an input symbol where it is reaching Q3. And so 1 is no input symbol for this one from the Q2. And if you take Q2, 0 as an input symbol, it is reaching the Q4. And there is no input symbol for the 1. And next Q4, so it is reaching the Q4, 0 for the 0 input symbol and 1 also. So for one input symbol also it is reaching Q4 only. So in the transition table, we have to represent with this initial state and final states like this. So here is the construction of transition table. And next inputs in 5-tuple notation, transition after that initial and final states. What is the initial state in the sense? The Q0 is the initial state and final state is the Q4. Q4 is the final state. Initial state. So like this, the construction of NFA will be followed by 0 or ones followed by the zeros, double zeros. And next example. So draw a NFA for the language L. All the strings over 0, 1 that have at least a consecutive zeros are ones. here is the example with the construction. So we have to elaborate the language. So here we have to elaborate the language consecutive zeros or ones. So here is the two conditions like so the language which is having either 0 or 1. So these two conditions should be satisfied. So we can start with 0, end with something 1, 0, sorry 1. We can end with anything. So the condition is consecutive zeros and consecutive ones. And here we can add two more lengths to this one. 0 should be there. 1 and 0. You can add 1 0 0, and here also 0. We can extend up to how many lengths we require. We'll just add to that. We can elaborate that language. For this kind of language, we require the two conditions should be satisfied. We have to satisfy either the string starts with a 0, and we can have to satisfy the string with double 1 also. For this condition, we require the length like so 2 plus 2 4, and we require one more state. 5 states we require. So minimum length both the 2 plus 2 and plus 1. We require 5 states for this construction of NFA. And how this construction of NFA in the sense, first we have to start with the Q naught, and these two conditions, though here in the main difference with the NFA and DFA, for the input symbol we can also from one state we can add multiple input symbols. So that is the thing which we are having in the NFA construction. So here is the thing how to construct a NFA for the consecutive zeros over or ones. So here the Q naught is the starting state, and from the combinations 0 should be satisfied and 1 should be satisfied. How this 0 going to be satisfied in the sense, here we in this entire NFA construction we have the two final states here, the like Q4 and Q2. And as we discussed earlier, the 5 states we require. So to entire satisfy for the two substrings like 0 and 1. So here the 0 is satisfied with this path. So and from one state we are having the two input symbols. So this is the thing. What is the difference? Main difference for the NFA and DFA. So here 0 should be satisfied. After that we can add multiple zeros and ones for the starting and ending. This path should be like this. The starting either it is 0 or 1, it should be satisfied with this loop, and ending either 0 or 1, it should be satisfied with this condition. And for the same thing, double 1 should be satisfied. In the same diagram we have to represent this condition also with the another path, and 1 this path is going to be reaching the final state. And here also the starting we can add 0 or 1, and final we can add 0 or 1 with this, that is satisfied with the 0, 1. So we can check all the strings with this NFA construction, so whether it is reaching the final states or not. So for the same thing we can represent the conditions 5 tuple notation. So 5 tuple notation require how many states we have, like here we are having the 5 states Q1, Q2, Q3, Q4, and next delta. So delta is a transition function. We have to represent how many states it is going to for the input symbols. And next our sigma, which is having the zeros ones combination. And next starting state is the Q naught, and final states are here. Final states are 2 states. So we have to represent like Q4 and Q. It is a subset of all the Q states, subset of Q states. And next example. So draw a NFA for the language L, all strings over 0, 1, that the string starts with 1 and ends with 0. So the string starts with, we just elaborate the language, the string starts with 1 and ends with 0. So in between whatever it is, we can just write just a minimum length here satisfying for this string. So 1 0. So 1 0, the starting with 0, starting with 1 and ending with the 0. And in between we can add either 0 or 1. So either 0 or 1. So in between we can add. The condition is the starting with 1 and 0, ending with 0. And we can add minimum length to this one, 0 0 or 1 0, 1 0, 1 1, in between 1 and 0. So like this we can form many strings. So like this we can form many strings like this. So here the how many states we require for this NFA construction in the sense, if Q is equal to, so Q, how many states are required in the sense, minimum length is 2, minimum length is 2, 2 plus 1, we require 3 states. So here the 3 states in the sense Q0, Q1, just take these 3 states, Q2. So let's construct a NFA for this one. So starting is Q0. So we have to satisfy the first minimum length. So we require 3 states. First condition is the string is going to be starts with 1 and ends with 0. The minimum length is satisfied by this construction, and after that in between any 0 or 1 comes, it is also have reached the final state. So it should be satisfied with this loop 1. So if the condition should be satisfied, the condition, the starting and ending is condition. So the starting with 1 and ending with the 0 is the condition, and next how many times 0 is there, we can just represent with the loop. And here if we, after ending, in case of final string, the 1 is having, it just go to the Q1 state. So this is the construction of NFA for the language. The string starts with 1 and ends with 0. For the same thing, what are the states we already write. So how many states we require in the sense, minimum length is 2 and 1 is the added. So minimum length is 3. So here the 3 states are required. And transition delta. So for delta transition, so we require the states Q0, Q1 and the Q2. So 0 and we input symbol 1. So here the alpha is equal to 0, 1. So from Q1, Q0, so 1, there is 0 input symbol, there is nothing. And for 1 input symbol, it is reaching the Q1. And Q1, for the input symbol 0, it is reaching Q2. And from the input symbol 1, it is reaching Q1. And next Q2, from Q2, 0. So it is reaching the Q2 only. And next when it is comes to the 1 input symbol, it is reaching Q1. So starting state and final state, it should be represented. And the initial state is Q0 and final state is Q2. So here is the phi tuple notation for the construction of NFA. And these are all the examples of construction of NFA with the diagrammatic representation and the phi tuple notation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.